In this training video, we're going to discuss downstream constraint. Downstream constraint is a method which is used to create 3D polylines that flow in a downhill direction. This method is useful for creating breaklines that hydraulically enforce streams. And to start with, we're going to open up LP360. You can see already I'm zoomed in into a segment of a data set that's been classified. You can see the ground and some water points have been classified. We're going to be using those as our source points for doing this. First thing you want to do is you can see in the table of contents here, I've got my Point Cloud Task tab. So I'm going to open that up, and we're going to create a conflation method for performing this process. So you'll click on this gear icon in the top right and click Add, and you can see for our task type we want to choose conflation. You can name it whatever you would like. For this example, I've named it Downstream Constraint. For input geometry, you're going to select Tool Geometry. Input Las Layer, you can set up how that's going to be, how this conflation method is going to be picking those points. Usually I just have that set to active Las Layer. For source points, this is important. Let's go ahead and click on that, look at those settings. I have it set to use our ground points, and you can also see some of these legacy classes for older data sets. I've chosen those as well, so 8, 10, 20, those classes, we'll choose those as well in case you're working with a data set that would have some of those points classified in that way, okay? So I've got my source point set. Now this is the most important part. Let's choose our conflation method. You'll click in this data types menu, you'll click conflation method. This could be set to like this. Whenever you first get into it, you'll just click once in here, you'll get a drop down and then choose downstream constraint. Once you choose that and click on it a couple times, it's going to pull up this menu, and we can adjust some settings. More than likely, what you'll want to do is create a vertex for X amount of map units. It just depends. So for my scenario, basically drawing this downstream constraint polyline in the middle of a river that's pretty well defined. There's not a lot of fluctuation going on for this feature, so I may want to do maybe every 10 map units. But let's say you're doing some riverbanks, and the ground is really changing a lot. You might want to choose an option like pure drape, something like that. Okay. You could choose get Z for existing vertices if you already have a feature and you're applying this conflation to an already existing feature. Or let's say I draw this and I'm not happy with it. I could always choose this this setting if it was an already drawn feature and you want to apply it that way, okay? Hydrology constraint errors, I'm going to have that off, but if you have this on, it'll give you a fail if you start drawing upstream, or it'll flip geometry if drawn upstream, okay? You can have it do that. I'm just going to basically have it not fail if I accidentally draw upstream. Deltas here, you can display warnings if you've got deltas exceeding whatever this value for your map unit. So that this is set to 1, this is for the map units of feet. So every time that I get a fluctuation that's more than a foot, it's going to give me a warning message, and you can also set your delta summaries here as well. So I'm going to set those on, but I'm going to turn the display warning off. And it says here that these delta values are stored as M values with output geometry. So we're going to, whenever we get to that point, we're going to have it set to turn on writing those M values when we get to that point. I'm going to click OK. If I scroll down here, The one other thing you have to set here is, even though we're basically just defining how this conflation is going to be done, so we don't really need an output path, but the way that the point cloud tasks work, or a lot of them work, you do have to set up a project path no matter what. So a lot of times for this kind of situation, you can see here if nothing's set up, I'm going to clear that out. It should, it usually will give you a validation error here on the left, but a lot of times I'll just go in here and select insert LP360 project path, and then your validation error goes away. This isn't really a valid path for writing a shapefile, but we don't really care because we're just using this to determine our completion settings. Go ahead and click apply. So we have that set up now. Now what we're really wanting to do is to use this in what we call our AutoZ function. So as I'm drawing the feature, the conflation method is going to be automatically applied while I'm drawing it. And this is a feature in the feature edit toolbar. This is also where we're going to be setting up creating the feature as well. So the first thing I want to do is go to this is my feature edit toolbar. Okay. On the right here, we have our feature edit options dialog. I'm going to click on that. You can see we've got some different tabs here. We're going to focus on this AutoZ tab for the settings. You can see I already have my downstream constraint conflation task set, but if you had not set up any conflation tasks yet and you just set that up, you would select it from the drop down. And I have it set up to for my edit and create feature conflation tasks. So just keep that in mind that you can have different conflation tasks or settings set up depending if you're editing or creating features. Click OK. The next thing I want to do is we're going to set up what type of feature this is that we're trying to create. So I'm going to go ahead and click on the create feature layer. This time we do need to set a path. I'm going to call this river polyline. Well, let's call it river center line because that's what we're making. And save. Geometry type, you want to choose 3D polyline, and we're going to enable M values. And so the M values are significant. You'll see this later because this is going to tell us how much the feature that we're creating, this downstream constraint feature, is deviating from our actual point cloud. So you know, the general rule here is that we always want to go downhill, right? We don't. We know that this stream is decreasing in elevation constantly. There's at no point is it going to be, you know, increasing in elevation. We're flowing downstream to a bigger river system, so we know we always have to go downhill. And with any of these data sets, even ones that like this one where there's really not a whole lot of noise, there's still enough noise to where you know, you could possibly, as those points fluctuate, they could be kind of going up and down in elevation. But we want to have a constant, you know, a decrease in elevation. That's the whole point in doing this. So enabling those M values will tell us how much it's deviating from that point cloud, and we'll show you examples in a little bit. Hit OK. And just to mention this as well, it's important to segment or make separate features when appropriate. An example would be if a river was flattened out and this segment needed to be a consistent height. So, you know, right now we're drawing, you know, in this part of the river, we're constantly going, you know, downhill. There could be a segment of the river that's dammed up or something like that, or we know it's flat. Then you would draw a separate segment with your AutoZ off. See, we have our AutoZ up here. I can turn it on and off, and then you can connect those segments later. We would use you could use a feature separation tool to cut already existing features, or more than likely what you're going to be doing will be using a snapping tool to combine these separate features into one downstream constraint line. You just want to, and I'll go into this in a little bit, but you'll want to edit those vertices to where they match up if you're combining separate segments, going from downhill to flatten to downhill again. And also keep in mind that your downstream constraint adjusts the beginning and ending points of the line. So this can affect the snapping features midline for that situation I was just mentioning that correspond to specific elevations. So again, you'd have to use that snapping tool to fix that in that kind of scenario. And once this input geometry is draped to the LiDAR surface, a downstream constraint algorithm is invoked on the output geometry to ensure that the vertices will flow downhill. And this tool is directionally based, so if the feature is drawn in a general downstream direction where the start point is higher than the end point, the Z values of the output line will lower the original draped values. And this is kind of what I was describing earlier, but this is what we kind of call the burning effect, where the feature will be cutting through that point cloud if you got any noise. So, and we'll show that here in a second. So to start with, I'm going to choose Create Feature right up here. Okay. And I'm just going to zoom in a little bit, and we're just going to be drawing that river center line, okay? And it's going to be using that downstream conflation method we set. So I'm going to left click. More than likely, and especially so in this example, this is a nice, easy to follow stream. A lot of users are probably going to be wanting to draw drainage ditches, stuff like that. So you have a V-shaped drainage ditch, so you'd only need the center line for drawing it. And if that's the case, you're really going to want to make sure you're at the bottom of that V. You can see here I've got this nice flat, wide river. But if you're doing a drainage ditch, it might just be a small little V. If that's the case, you want this profile line to be perpendicular to the direction, or your cross section to be perpendicular to the direction of the stream flow. And you can see by default it picked this direction. If I want to alter that, I just move my mouse into the profile window and then hold down Shift, and I can use my arrow keys to shift that to where it's perpendicular to the downstream direction, okay? And that way you can see, oh, I'm hitting the middle of that V for doing my draw. So I'm just going to do a few vertexes here to demonstrate how this would work. So I'm going to left click. It's going to make vertexes in between these clicks every 10 map units. That's every 10 feet. And of course that would be different depending on how you have that set. Okay. Again, let's say I'm not happy with the way that is in reference to my stream direction, my cross section. So then I would hold down Shift and then use my arrow keys to change that. Okay. I'm just going to keep drawing for now. This is really off if you were trying to do like a drainage ditch or something. But if you're doing a drainage ditch, it would probably be meandering a bit less than this. You wouldn't have to change it as often. Okay, we're just going to follow the center line of the stream. We're just going to do a few more here. And I'm just left clicking to create that polyline. And then I can double left click to finish. And then it's going to create that feature. I have the option up here, if I hit the floppy disk, it'll save that feature I just created, or if I'm not happy with it, I can just choose the trash can and start over. So, okay, that's a nice color to yellow. I can distinctly see where I've drawn that feature. We're going to go ahead and save this. So we're going to confirm that. And I'm just going to very quickly, this isn't the best data set for this because it's not really that noisy, but I'm just going to show off this burning effect, so to speak. So I'm going to draw a profile line that's in line with the stream. And we're going to zoom way in on these points, okay? let's make our points just a little bit bigger here so you can see what's going on. Okay, there we go. So I just went to live view filter, and you can see depending on what views I have chosen for the settings, I can increase the point size. So let's increase it even a little bit more. Okay. All right, so you can see my water points, and you can see how the feature line is quote unquote burning through those points. Okay, so it's not matching it perfectly, and that's because it's going to automatically constantly trying to go in a downhill direction. Okay, see what's going on there? All right. So with Feature Analyst, which we're going to look at next, we can use this to verify our downstream constraint. This downhill vertical test does not work on polygons that we're going to be using here in a second, but it does work on polylines that we've just drawn. With the feature we just created, selected, we're going to choose this option. So I'm going to go to Table of Contents. You can see we've got a river center line created. We have a feature. Right click on that, go to Feature Analyst. Click on the Feature tab. You can see that there's the line we created. If I go into our settings up here, for vertical, you can see we have a downhill test. So we can see if that failed, okay? One thing I want to do too, so I doubt this is going to fail because I probably drew it correctly. I'm just going to edit one of the vertices. I'm just going to throw it out to the side here. And I'm going to, we're going to see how that fails. Hit save here. Okay. Go back to settings. We have that downhill set. And I'm going to select this feature, go to vertices. We're going to look at a few different things here. So you can see we've got our deltas here. Those M values. So you can see how the line is differing compared to the actual point cloud. I'm going to turn on I'm actually going to analyze that downhill direction. It might not have saved that point just because I made it so odd here. Let's see. Let's do something like this. Regardless, if we had that point somewhere in an uphill direction, it would fail on this dialog. Because I drew it correctly, it's not going to fail. So let's look at this one area with this bridge over here, where we can see that the water was classified incorrectly. And let's look at that in the profile view. Let me zoom out here. You can see here, see how the water classification's up in the air, and that's because it's a bridge. If we look at some of those vertices, you can see the M values for those are going to be quite high. You can see 19 feet. So that's just telling you that it was making that correction to keep that center line going in a downhill correction or direction. It had to make a correction of that much, or it's that far off the point cloud for it to keep on going in a downhill direction. You can kind of use that to troubleshoot if you had any issues with how the downhill constraint was done. Again, this is one of the tests too. This is going to tell me because we have that downhill test, whether all these points are going in a downhill direction or not. So if I draw an uphill at some point, or there was some issue with the way that was done, it would tell me right there. And you can see we can make adjustments in the profile view here, or you saw me changing or moving the point in the map view if I needed to make any edits, okay? And so that's what you would do. You would navigate to adjust problematic vertices by clicking on that row of the non-constrained vertex, which will likely be in a row after the vertex that failed, just like we saw in the feature analyst. So we didn't have any bad points, but that's how that would be done. This concludes this demonstration. Hopefully that gives you an idea of how this downstream constraint works. This is just a basic demonstration of setting that up and testing it. In later training videos, we're going to go over basically creating some additional features for wide rivers like this, where you would want kind of a double line on either side of this, and not just the center line here. This would be a good scenario where you just have the single center line for if you're doing a V-shaped drain or something like that. But we'll be discussing that in other training videos. We basically determined how to create, edit downstream constraint features. If you've got additional questions, or you need additional support, please email support@geoq.com. And thank you for watching, and have a good day.